So section 7.5 is solving rational equations, and we're going to look at a couple of ways to do these. First way is to do it by solving by cross-multiplying. So you can use cross-multiplying to solve a rational equation when each side of the equation is a single rational expression. So that means it's one by itself. So like on the first example here, of course, I'm going to give you two that are exactly like that, because now it's telling me I can take and I can cross multiply here because it's equals. So I'm going to take 2 times x, 2 times 3x plus 2. And then I'm going to take the other one here, and that would be equals 10 times x plus 2. So now we're just going to distribute that 2 through the parentheses. So I'll get 6x plus 4. That 10 through the parentheses, 10x plus 20. Now I'm going to solve for x. I'm going to take away 6x, so that'll give me 4x. I'm going to bring the 20 over to the other side, which will give us negative 16. Now I'm going to divide by 4. That'll give me that x is equal to negative 4. All right. Now you have time, ladies and gentlemen. I'm giving you time on your test. So you should always plug them in just to make sure. I'm not going to right now for the sake of speed here. So check your answer in the original equation. All right, here's one more here. So we're going to do the same thing here. So on this one here, and I'm going to multiply those two. So I'll have x times 2x plus 5 equals, I'm going to do these two here. Well, 1 times anything is just going to be the anything, so it's going to be 11x plus 8. So now I'm going to distribute that x through the parentheses. That'll give us 2x squared plus 5x is equal to 11x plus 8. We know, since I have a squared term there, we know it's going to be a quadratic, so I'm going to bring everything over to the left-hand side and set it equal to 0. When I simplify, I'll get 2x squared minus 11x that was a 5x there. That's why I wasn't working out. So that'll be 5x minus 11x. Again, I'm not going to stop it for that. I noticed my mistake. So I'm going to have a negative 6x minus 8 is equal to 0. Again, we can factor out a 2 there. When I factor out the 2, I'll get x squared minus 3x minus 4 is equal to 0. Again, you're going to divide by 2. 0 divided by 2 is 0. Now let's factor that. So again, I have an x, I have an x. I keep telling you, look at this sign. If it's negative, you know that one's going to be positive and one's going to be negative. And what are factors of 4? That will give us negative 3. So you'll tell me it's minus 4 and plus 1 is equal to 0. So by this, we can tell that x is going to equal negative 1, or x is equal to positive 4. Again, check your solution. I'm going to tell you right now it's okay. But do that, ladies and gentlemen. Again, you might have, remember, an extraneous solution, and you don't want that. Okay. Example 2 is a word problem, and there is a word problem exactly like this on the test. I mean, we're going to have to do something similar. So, an alloy is formed by mixing 2 or more metals. White gold is an alloy composed of 75% gold and 25% palladium by weight. You have 12 ounces of an alloy that is 60% gold and 40% palladium. How much pure gold should you mix with this alloy to make white gold? All right. So since you know the total weight of the palladium in the mixture and you are not changing it, you're not changing the palladium, you're going to use the formula. The percent of palladium in the mixture is the weight of the palladium in the mixture plus the total weight of the mixture. So our percent of palladium in the mixture, it tells us we have 25%. So 25%, that is going to be 25. And remember, percent is per 100. And the weight of the palladium, again, they're telling us the weight of it is 40%. We never use a percent. We would change that to a decimal, so we're going to say it's 0.4. All right. And how many ounces was there of that mixture? There's 12 ounces. Okay. And we're going to say let X equal the amount of pure gold added. All right, so if I have that, I have already total weight. We have 12, but we're adding some more to it. We're adding some pure gold to it. So we're going to say it's 12 plus X. All right, hey, that looks exactly like the ones we were just doing up above. So I'm going to take and I'm going to multiply the 25 times the 12 plus X. I'm going to multiply the 100 times the 4.4 times the 12. So I just told you what I'm going to do. So I'm going to take 25 and I'm going to multiply it to the 12 plus X. And then I'm going to take 100 and I'm multiplying it to 0.4 or 4/10 and 12. All right. So if I do this, if I distribute that 25 through the parentheses, 25 times 12 is 300 plus 25x. When I take 100 times 0.4 times 12, you plug that in your calculator, you'll see that you'll get 480. All right, so now we are going to subtract the 300. So 480 minus 300 is 180. And now I'm going to divide the 25. So 180 divided by 25 tells us that the amount of pure gold that we're going to have to add is 7.2. 7.2 what? Looks like we were talking about ounces. So remember, OZ is the short for ounces, and that is our answer. Okay? So again, pretty straightforward. There is one like that on the test. Okay, there's one like it on the practice test too, so that'll help us. All right, so let's see. Solving using an LCD. So when a rational equation is not expressed as a proportion, you can solve it by multiplying each side of the expression by the LCD of the rational expressions. So remember, on this one here, if I just had the 3x, okay, so if I didn't have this, if I just had the 3x, then I could use my cross products. But since I don't have that, I have a plus or minus sign there, I'm going to have to go ahead and use my LCD. So the easiest way to do that, ladies and gentlemen, is look at what's on the bottom, all right? And I'm just going to multiply what I can together, all right? So our LCD here, all right, I see that I have a 2 in one of them. I have an X in 2 of them, but remember, it's the same power, so I'm just going to use it as 2X. So now, that is what I'm going to multiply everything by. So think about that. So I'm going to take my 2X, and I'm going to multiply it to everything on and let me see. I'm just going to show it. Let me see. I'll go ahead and put it on both sides this time, just to show you. And again, I'm going to multiply both sides by 2x. Now, just think about what's happening here. So when I multiply it, the 2x to just the 3x there, the x's are going to go away. So what we're trying to do here is we're trying to get rid of the fractions, and that's what's going to help us out here. So if I multiply just the 2x to the 3 over x, those are going to go away. I'll have 2 times 3. What is 2 times 3? 2 times 3 is 6. So I'll have a 6 for the first one there. I still have that plus sign there. That's not going away. So now I have the 2x times the 5/2. What's going to go away on those ones there? The 2's. So what do I have left? 5 times x, or 5x. And on the other side here, same thing. I'm going to get rid of the x's because there's one on the top and the bottom. What do I have left? Negative 12 times 2. And what is negative 12 times 2? That is negative 24. All right. So now I'm going to take, I'll have 5x. I'm going to move that 6 over to the right-hand side, so it'll become negative 24 plus a negative 6 is negative 30. And now when I divide through by 5, I'll get that x is equal to negative 6. Again, check your solution. Because, even on the platform, when you're taking your test, it will get, if you put both of them, it's going to mark it wrong, all right? Or if you put more than one, or, okay, you know what I'm talking about. All right, so same thing here. Let's do the same thing. So our LCD, let's see. Well, I have 1. Well, there's nothing on the bottom for there. It is technically 1 over 1 if you want to think about it that way. That might help you out. But let's see. I know I have x minus 4. And I know I have an x. And again, I'm going to do the same thing here, people. I'm going to take my 1 and minus 2, x minus 4. And again, I'm going to multiply this by x minus 4 times x. And then same thing on the other side. Oops. The 4x, 4 over x, excuse me. And I'm multiplying it by x minus 4 times x. And we're going to do the same thing as we did on the last one. And here, let me go ahead and put this over 1 again for you. But on the first one there, again, I'm trying to get rid of anything on the bottom. Well, on the bottom, we just have a 1. So looks like for the first one there, when I multiply through, I'm going to have x times x minus 4. All right. Now for the second one there, what's going to go away? The x minus 4s, and what do we have left? X. So I'm going to have minus 2x And on the other side, what's going to go away? The x's, and I'm left with 4 times x minus 4. All right. So I hope you see what I just did there. So now let's go ahead and simplify this. So again, I'm going to distribute. That'll give me x squared minus 4x. I have that minus 2x still. And then on the other side, I have 4 times x, or 4x, and 4 times a negative 4, or minus 16. Just like we did on the other side, we're going to put everything on one side. I'll even put that there for you. On one side. So if I do that, well, the x squared is going to stay the same. I have negative 6x there. I'm going to bring that 4x over. It's going to become negative. So I'll have a total of negative 10x there. And when I bring that 16 over, it's going to become positive. And then on the right-hand side, I just have 0. So now again, we're going to factor, just like we did on the top one. So if I do that, let's see, I have an x, and I have an x. Again, look at this one here, it's positive. So when that one's positive, we look at that one there. That one's negative. So that tells us we're going to have 2 negatives there. And what are negatives that are going to, let's see, when I multiply them, give me a positive 16. Yet when I add them, give me a negative 10. It would tell me 8 and 2. So again, x is equal to 8, because 8 minus 8 is 0, or x is equal to 2. Again, because 2 minus 2 is equal to 0. So remember, again, I'll put it one more time. Remember to check, because one or both solutions could be, and remember the word that we used was extraneous. And again, those of you moving on to trig, you'll still see extraneous solutions there too. All right. So let's see, we're getting done here. Let's see. So I have continued. I did it all in one day this time. So when solving a rational equation, you may obtain solutions that are extraneous. Be sure to check for extraneous solutions by checking your solution, not you solution, your solution in the original equation. So let's go ahead and do this one too. All right, so let's see, why don't I, let's see, again, we're going to factor the bottom first. When I factor the bottom first, on the first one I'll have 4x. Remember, that's x squared minus 9. That is going to be a difference of squares. So that'll be x plus 3, x minus 3. On the other one, I have x minus 1. Let's see, when I factor that, I'll have x minus 3 times x minus 3. I'll go ahead and leave it right like that for the second, but again, we're going to see that we're going to have to do something there. So then I'll have 2, and then I have x plus 3. So on that one, I didn't have it to factor anything. So remember now the LCD, and we talked about that earlier. We take what we see. So we see an x plus 3, and we see an x minus 3, and then we're going to take the highest power. Remember this one here we can write as x minus 3 quantity squared, so that would give us that. All right, so now I'm going to do the same thing, just what I just did here. So I'm going to take my LCD, all right, and let's see here. How did I do it on this one? Yeah, it looks like I'll just go ahead and write it down for each one of them for you. So we have x plus 3, and then we have x minus 3 squared. And I'm going to be multiplying that to my 4x. Over x plus 3, x minus 3. And then I'm going to do the same thing. So I'll have x plus 3, x minus 3 squared. And I'm going to multiply that to our x minus 1 over, and let me go ahead and leave it as x minus 3 squared here so you can see it easier. Then we'll have plus, again, let's do it one more time this time. And then I'll have my 2, and I have x plus 3. All right, so on this one here, I wrote it out more for you so that hopefully you can see it. So on the first one here, what's going to go away? X plus 3 is going to go away, and 1 of our x minus 3s are going to go away. So what do I have left on that one? I'll have 4x. And I told you we're going to have 1 of our x minus 3s. Okay? On this one here, let's see, x minus 3 squared and x minus 3 quantity squared is going away. What is left there? You're going to tell me you have x minus 1 times x plus 3. And then finally on the last one there, what's going to go away? Oops, didn't mean to do that. I had x plus 3. And again, the x plus 3s are going to go away. Let me put it as my fraction left. And so I'm going to have plus 2 times x minus 3 squared. All right. So now we're going to do just like we just did before. We're going to factor everything and set it all on one side, set it equal to 0. So I'll have 4x squared minus 12x on this side. Again, I'm going to FOIL these two. So FOIL. And if you did that right, you would get x squared plus 2x minus 3. And on this one here, I would take my 2, and since I had this x minus 3 squared, remember that was just up here. So we're going to multiply everything up there by 2. So if I do that, I'll get 2x squared minus 12x plus 18. All right, so let's see here. Now, what am I going to do? Let's see. Why don't we just go ahead and simplify the one side first? And if I do that, set up 2x squared and an x squared, so that'll be 3x squared. Let's see, I have 2x minus 12x, which would give us a negative 10x. And then let's see, I have a negative 3 and an 18, which would give us a positive 15. Now let's set everything over to the other side and set it equal to 0. So I'll have 4x squared minus 3x squared. That'll give us x squared. Negative 12x minus negative or plus 10x, that would give us minus 2x. And then when I bring that 15 over, it's going to become negative. And I'm going to set it equal to 0. And let's see here. If I do this, I'll have, let's see, x minus 5 and x plus 3. Trust me, you'll see that'll work. So by the zero product property, x is equal to 5 or x is equal to negative 3. Okay? So again, check for extraneous solutions. All right, and on this one here, let's just go ahead. I'm going to show you the one that's not going to work. Because if I plug in x is equal to negative 3, and again, if I plug it in just to the first one there, I'll have 4 times negative 3. And when I say the first one, I'm talking about this, because remember, we're going to plug it into the original equation. And then I'll have negative 3 plus 3, and negative 3 minus 3. But what happens here? That equals 0, and we know we can't have a 0 in the denominator, right? So when we do that, we know that this one here is extraneous. I'll tell you if 5 works. It gives you a fraction, but it does work. I'm just kind of showing you what you have to do. All right, now I put these ones in because there's one similar to this test, but we've done these ones before already, people. So I'm showing you why I'm doing them here. And then, there's one like one of these on the test again. And then I'm going to show you how to do it for our last example too. So on the first one here, remember, our goal was first we're going to write this as a y, right? F of x is a fancy way of writing y over 7x plus 5. All right? So now remember, you're supposed to switch the x and the y. So if I do that, I'll get x is equal to 7 over y plus 5. And we're going to solve for the new y. I remember last time I put it in quotation marks. So if I do that, now look, if I write this as x over 1, then I can use my cross products. So I can say that x times y plus 5 is equal to 1 times 7, or 7. Oh, sorry, here, let me put the right color. All right, now we're going to solve for that new y. So if I divide both sides by x, I'll get y plus 5 is equal to 7 divided by x. And then to get y by itself, I'll have y is equal to 7 divided by x minus 5. And remember, your textbook likes to call it g of x. All right, so I just wanted to show you how both of these kind of look the same, but they're slightly different. So on this next one here, I'm going to do the same thing. All right, so I'm going to go y is equal to 12 over x plus 9. We're going to switch the x and the y. So now I'll have x is equal to 12 over y plus 9. All right, so now I'm going to have to get y by itself, but first thing I'm going to have to subtract the 9. And now to get y by itself, I can't have it on the bottom, so I'm going to multiply both sides by y. So I'll have y times, again, I already had the x minus 9 there, so it has to go in parentheses. And now to get y by itself, you're going to divide by x minus 9. Since I already put it in parentheses, it's going to stay in parentheses at the bottom. And again, our textbook will call it g of x. All right, so I guarantee you there'll be ones like that, like either A or B. Okay, not both of them, but like one or the other. All right, and then the last one here is the average cost in dollars. So we're using a word problem. Plotting the in blueprints using a plotter is given by the function c is equal to 25n plus 1500, all of that divided by n. All right, so now what it wants us to do is express the number of blueprints in terms of the average cost. All right, so now on the last one there, we switch the x and the y. So usually we do switch the variables, but in this case, the variables are meaningful and switching them to find the inverse could lead to confusion. So solve for n without switching the variables. So I'm going to show you how easy that still is to do. So we have c is equal to 25n plus 1500, all of that over n. So now I have an n on the bottom there. So to get rid of that as a fraction, I can multiply both sides by n. All right, so now see what happens here. The n's are going to go away on that one there. And again, we like to put them in alphabetical order, technically. So we're going to say that c times n is equal to 25n plus 1500. All right, now I have an n here, I have an n here. So I'm going to bring that 25n over to the other side. So I'll c times n minus 25n is equal to 1,500. Now, I have the n's on one side. I have to solve for n. So I can factor out an n because there's one in each one. And then what I have left, c minus 25. And then to get n by itself, what are we going to do? We're going to divide both sides by c minus 25. Those ones are going to cancel. So I get n is equal to 1,500 over c minus 25. Again, there's one of these on the test too. That's why I left it in here. All right. So that's it, people. And that's our last section.